right, so again, this is just kind of going over what the second part of your trip lab project is, which is finding the sums or the area underneath the curve by using the left-hand Riemann sum, the right-hand Riemann sum, midpoint, and trapezoidal. So on your paper, you should have drawn x squared graph. Something like this. So let's go and label this just f of x equals x squared. And we're going to be looking particularly on the interval 0 to 4. And let's just go ahead and say delta x is what that means. Okay, so the purpose of the second part of that trip lab project is to get you to kind of investigate how do we find the area underneath the curve. So if I'm going from 0 to 4, I know this is not drawn to scale, but let's just pretend this is 1, 2, 3, 4. So basically what we're trying to do is find the area under the curve here, so all of this area. Now for this particular one, if we look at it, we could probably get a triangle pretty close to that, estimate it that way. But of course, as the functions change, the shapes that you would want to use would change as well. So, and we'll learn about this, I think it's unit 3 that we're going to talk about this. But there are a few different ways that you can approximate or estimate that area in the curve. So we have our left-hand Riemann sum, which is drawing rectangles using the left endpoint. Our right hand, which is drawing rectangles using the right endpoint. Our midpoint, which is drawing rectangles using the midpoint, or trapezoid, which means use trapezoid instead of rectangles. Okay. Now, if this was, say, some piecewise function that looked like this, then we could find out that area underneath the curve by using different geometric shapes. I could do a triangle there. I could do some type of trapezoid here. But what we're going to be focusing on for our trip lab is using those rectangles and then ultimately the trapezoid at the end. All right. So starting off with our left-hand one. So the MH is how it's for your trip lab. So the left-hand sum is where we draw rectangles with heights using the left endpoint. Okay, so rectangles with heights is the left endpoint. So what this delta x tells me, this is my width of the rectangle. Or when we get to a trapezoid. So then to find the area of a rectangle, it's length times width or width times height. So we've got our width, but we have to find our height. So what we're doing here at the left-hand sum, I'll go back to red, since red is red. Okay, so if I draw my rectangles, my height using the left endpoint, so my delta x, the width is 1. So I'm going to be going from 0 to 1, 1 to 2, 2 to 3, 3 to 4, because that's that length of 1. Okay, so from 0 to 1, my left endpoint would be 0. What is my height at 0? 0. So that's actually not very exciting. That gave me no rectangle, no height. Okay. So then my next rectangle from 1 to 2, my left endpoint would be 1. So I go up to the height for 1, and that's what I use to draw my rectangle. And then going from 2 to 3, my left endpoint is 2, so I go up to the height for 2 and draw that using my rectangle. And then from 3 to 4, I use the left side 3, so I go up to my height for 3 and draw my rectangle using that. All right. So as we can see, we have 4, but really just 3 rectangles since my left one had no height there. Now to find the area for each one, we could do length or width times height, But what is going to be my height for this first rectangle? What is my height there? 1, right? How did you know it was 1?
Plugging x5 into the function.
Yeah, we take our x5 as a function. We know that this height is f of 1, which for this case is 1. And likewise, my height for this second rectangle here would be whatever f of 2 is, which for us would be 4. And then same here, this would be f of 3, and those would be my different heights. So then I could go ahead and go through and find my area by finding the area of each rectangle and adding those together. Now, for this particular problem, do you think that's going to be less or more than the actual area? Looks like less, right? But that changes depending on what type of graph you have. So don't just automatically assume that left is less. Okay. Now, the right-hand sum is going to be a similar thing. It's rectangles with heights, but instead of those heights being determined by the left endpoint, we use the right endpoint. Okay. So now if I look at my graph using the right endpoint, again my width is 1, so we're using that same width, that same chunk of board. So now when I do this, you can start off on the left side. I'm going to start off on the right side. So from 3 to 4, I'm going to use the height for 4, whatever that may be. And that is my height for that first triangle. And then from 2 to 3, I'm using the right side, so I'm going to go to my height for 3. And that is my, can I say triangle? Rectangle. That is my rectangle. And then again, from 1 to 2, I'm going to use the right side, so whatever my height is at 2, find that area. And then from 0 to 1, I'm going to go to whatever my height is for 1, and that would be my rectangle. So here we actually have 4 rectangles. And then again, similar thing, but now my heights are different, right? Now my height is based upon the right side. So what is my height of this rectangle from 3 to 4? F of what? F of 4. So notice now we're using the right endpoint, whereas before we used the left. And then same thing, this would be now, we'd have that F of 3, we'd have our F of 2, and we have F of 1. Okay. So just make sure you're careful that you're using the height depending on which side. So right hand side, you're going to be using the right side. Okay, questions on that? So can you guess what the midpoint one is? So midpoint, we still have rectangles. But what do you think my height is going to be based on? You guys think?
Middle of the rectangle.
What did you say?
Middle of the rectangle.
The middle of the rectangle. Okay, so rectangles with heights using, say, midpoint. So that's going to be my halfway between each of these values. I'm going to go ahead and just redraw my parabola since it's starting to look crazy here. Okay, so now for my midpoint, I have to do a little bit more work because it's no longer the 0 or the 1 that determines the height, but rather what value instead. For this first rectangle, what value determines the height? 1/2, yeah, 0.5. So I would go to my height at 0.5, and that would make my little rectangle. Then from 1 to 2, what determines that height? 1.5, and so on and so forth. So you now go to the midpoint. So you have to first find out what that midpoint is, and then you're going to go to that midpoint height, and that's what determines your rectangle. So again, similar thing, you can find the height of each rectangle by using now, instead of f of 0, f of 1, it's going to be f of 0.5. Questions on that?
Can you also do it sort of in the reverse fashion? So say take your height from the left side of the the right thing, or take the height of the right side and divide by 2 and change your height? Is that-
For this, because this is that nice metric that would work out, depending on the function of that. Other questions on this? Okay. So now trapezoidal. So now a trapezoidal, we change the shape altogether. We're going to use trapezoids. With, so we'll write this out. So base heights using the endpoints, both left and right, using left and right endpoints. Okay, so my trapezoids, remember your trapezoid has 2 bases. So the height of those bases is based upon my endpoint. So oftentimes, like in geometry, we'd always think of trapezoids like this, where this is base 1 and base 2. And remember, it's not always an isosceles trapezoid, and I could have had something like this, just as long as these 2 were parallel. But what we're going to be using for Riemann sums, think of this. Actually, let me turn sideways. So what we're going to have here is essentially, I go to my, so let's start on the left side here. I go to my endpoint for 3, go to my endpoint for 4. Those are my bases. And then here is that slate in between. Okay, so your bases are the height of F3 and F4. So let's see if you guys remember. Do you guys remember the area of a trapezoid formula? Okay, 1/2. Good. So 1/2 times the height times base 1 plus base 2, or you might have seen it written base 1 plus base 2 over 2 times your height, or maybe just on top, varying ways of writing it. So my base 1 and base 2 are going to be your F of 3 and F of 4, right? This is my base 1, this is my base 2. And then your height then, what is going to be my height for this trapezoid? Remember, your height is the distance between the 2 bases? 1, right? So it's kind of like it's turned sideways. Your height then is going to be the same for each of these, right? Because we kept them the same intervals. When we actually do Riemann sums, like in class, we might have different intervals, but for your triplet project, we said to keep that interval between the delta x the same. So here my height is actually just 1, but your base lengths are going to be dependent upon the function values there. So then similar thing for my chunk 2 to 3. So there's my chunk of 3. Okay, so for my chunk from 2 to 3, I go to my height for 2. We're going to have my height for 3, drawing that trapezoid. And then same for 2 to 1, drawing that little trapezoid. Okay, so you'll find your areas of each of those. So those are the 4 different graphs that you're doing. The left-hand sums on one graph with all your work. The right-hand sums on another graph with all the work. Midpoint sums on another graph with all your work, and trapezoidal sums on the graph with all your work.
Do we keep the areas of those separate things separate, or do we add it all together to find the total area?
Separate, because what you're doing each time is you're finding the area under there. If you were to add all 4 together, you'd be finding the area 4 times.
For the area for every rectangle or what have you,
Oh, sorry.
add it together.
Yes, so for each individual rectangle, like I would add all the green areas together. Then for my next one, I would add all the areas. Yes. Other questions on this? So that's what you're going to be doing for your triplet. And again, remember that triplet project, the data part, the explanation of your route, that is due coming up, what is it, next week? Yeah, next week. So the data, describe your route, and draw me the graph. Just the original graph without finding sums. That's due that first chunk. Then the next chunk due in October is the actual finding sums. Okay. So we're good there. And now let's take a look.